This volume of FactorX is about the nexus approach of sustainable development and resource productivity. Along with my colleague, Professor Raymond Bleiswitz, we did some research on the nexus approach regarding specifically hydroelectricity in Brazil. So the water energy nexus is an extremely good example of resource interdependencies, and one that is relatively easy to see as well for the common people. And it is one of the main ones, I believe, in the United Nations Sustainable Development Goals. One thing that we need to not do is to treat such research and such analysis in a silo type, like a silo type planning, which is actually what is going on at the minute. So this apparent relationship between water and electricity needs to be further explored. Up until this point, the resource nexus in general has been more or less a paper exercise. So we would like to go deeper, delve deeper into the data and find something that makes sense and that is applicable. So that's why we decided to concentrate more on the beginning of the delivery chain of the water cycle when it comes to electricity production, of course. And why did we decide to do this? This is quite important. Why Brazil? There have been some recent droughts in the country, and these droughts have unveiled water availability issues that affect the electricity sector. And of course, this happened in the southeast of the country, which is supposed to have a lot of water. And if a country and a place like the southeast of Brazil can have such issues, then you can imagine what can happen to the rest of the world. We need to quantify as accurately as possible the movement of water in, through, and out of a specific volume of water. This is for any kind of analysis, and of course it is really important for the analysis of hydroelectricity as well. These processes and the data that we need, the variables that we need, they're precipitation, evaporation, and river flow, which are the main ones. All of them are dynamic in nature. So obviously the modeling that we do needs to be also dynamic. It needs to take that into account. And this is why the spatiotemporal scales, when it comes to the analysis, are extremely important. We cannot just do analysis on a very large regional scale or the country scale. It is important to do this analysis on specific sites in each reservoir. And also the time step that we're going to use, it needs to be on a daily time step at the maximum. Because at the same time, I mean, you can imagine, water availability can change within a day. It can rain a lot. We can have a drought. These things change. And the main consumption for hydropower comes from evaporation, and that's why this is the one that we decided to analyze for the period of 2015 to 2049. And why was it important to do this research specifically for Brazil and specifically for evaporation? It's because there's only one other existing analysis that was done in 2004. And as we said, these things are dynamic. You cannot have an analysis that was done 15, 20 years ago and take the data and put it into a model. That doesn't make sense. You need to have something that is updated minimum annually. And this is why we started this, because we thought it was of the utmost importance. In general, I would say that we need stricter water impact assessments, and that doesn't only have to do with hydroelectricity, it's generally, but at the same time we are speaking about hydroelectricity here. So some important things to take out of this research that was done is that the evaporation rate is not going to increase uniformly throughout the year. As we said, this is dynamic and seasonality is extremely important, and we need to take it into account. At the same time, when we're talking about water footprints, there is no normal footprint that we can take and use in our models. We need to analyze every single reservoir on its own, because every single one of them will have completely different values. We cannot just take a median value and use it, because then the results that we'll have from our energy models, for example, they will be wrong. And except in a scenario of an extreme precipitation future, these water footprint values will also go up in the future, which will make problems even more important. From an energy perspective, I would say that this underlines the need for grid connections and seasonal backup supply provisions. And in some cases, in some reservoirs, plants, if it's impossible to increase the capacity of these plants. So our analysis calls for an overhaul of the electricity system of Brazil, with more integration across regions, upscaling of wind and solar, because this is important. As we said, seasonality is important for hydroelectricity, and that's why wind and solar could be invaluable. And a broader FactorX strategies as sustainable pathways for Brazil. There are opportunities that lie where we don't necessarily expect them. And something that is important to say, for example, about Brazil, because in the past they have tried to invest a lot into hydropower in the Amazon, which is not the greatest idea, because the capacity factors of those plants is not great. And at the same time, it is possible that precipitation will go down in the future there. Whereas at the same time, the southeast and the south of the country have more potential, but at the same time, we always need to take into account that hydroelectricity on its own is not the answer.